Hey guys, we are going to be covering the first half of section 3.2 in this video. 3.2, one of the most important sections that we're going to cover. It covers two ways of solving systems of equations algebraically, substitution and elimination. You've probably heard them before, but we need them to be muscle memory. We don't even want to have to think about them. So I'm going to go through, all we're going to do is just these notes on the screen right now, and then a few examples, and then you'll have some practice problems to make sure that you feel really comfortable with this process, because it is, if I could choose 3 things to make sure that you are rock stars at by the end of this course, this would be one of them. So substitution method, an algebraic way of solving systems of equations. In 3.1, we talked about graphing. And graphing and finding where our lines intersect all in one point, and so that's the solution. But graphing is not always precise. We're not perfect graphers. We draw our lines a little bit crooked, things like that. And so algebraic is often, and I will go and say most of the time, how we will want to solve these systems of equations. So today we're covering substitution in this video. Next video I'll make will be for the elimination method. But substitution goes something like this. I made a little checklist. If you like checklists, you can write this down. If not, that's okay. But first thing we do, we solve for one variable. We get one variable by itself. We isolate it. And then we substitute the definition of that variable into the other equation. Here's why this method is called the substitution method. We're just going to substitute it in. We're going to solve for the remaining variable. Substitute what we now know if, so let me put some labels on this as an example. If we got x alone at the very beginning, then we substitute an alternate definition in for x into our system, and we can solve for y. Once we solve for y, we know what y is. We can plug that value into an original equation and solve for x. Check our solution. Now, I went through that pretty quickly because you have seen this before, but we're gonna take our time going through some examples. So scrolling down, same 5 steps are right there. And what I'm gonna do is I'm going to look at this system of 2 equations. 2x minus y equals 3, negative 7x plus 7y equals 0. And we need to find an x and a y that work for both equations. Now, the first thing I would really advise you guys to do was step 1, solve for one variable, just get one variable alone. Look for the easiest one to get alone. My eye right now is drawn to this y, because it's not 7x, it's not 2x, I mean, it's just y. It is negative y, we'll give it that. But I think I can get that y by itself pretty easily. So I'm gonna say 2x minus y equals 3, that's where I'm starting. So maybe I subtract the 2x to the other side. We get negative y equals negative 2x plus 3, and then divide everything by a negative 1. So that becomes y equals positive 2x minus 3. Because remember, dividing by a negative 1 just flips all the signs. Now I'm going to put a half box around this. I don't want to lose track of that. That guy's going to be important here a little later on. But that was step 1. We solved for one variable. We got it alone. We're going to now substitute into our other equation. So I'll make this one my green equation, the second one. It was negative 7x plus 7y equals 0. But here's what I'm going to do. I'm going to say negative 7x plus 7 times something equals 0. And what is that something? That something is going to be 2x minus 3. And here's why. We know down here that y in this system of equations is equal to 2x minus 3. They are exactly the same thing. So instead of having y in my green equation, I'm going to substitute 2x minus 3 in. What does that do for us? Well, that actually does a lot for us, because now if you look at the green equation, all we have are x's, no y's. I made mention in an earlier video that to solve a system with two unknowns, you need 2 equations. Well, now we have just this green equation that only has x's. It only has one unknown. We can solve it with this one equation. Let's just follow kind of what our math instincts tell us to do. So negative 7x, let's distribute, plus 14x's minus 21 equals 0. Combine like terms. Negative 7x plus 14x is positive 7x's minus 21 equals 0. 7x equals positive 21. If we move that 21 to the other side, means x equals 3. I'm going to put a half box around that guy too. So we substituted our alternate definition in for y so we could figure out what x is. And now that I know what x is, check out what I'm going to do. I'm going to go back to my earlier half box, my y definition. I knew that y was 2x minus 3. Well, now I know that we are talking about 2 times 3 minus 3 because x was 3. I should change that color. I'm going to change the color of highlighting really quick so I don't have multiple yellows. But we're just substituting our known value of x that we just found back into our half box where we got y alone. And going through and saying, okay, well then y equals 6 minus 3, so y must equal 3. It looks like x comma y equals 3 comma 3. X being 3, that first number, y being 3, that second number. Now it looks this way, but I haven't boxed my answer yet. Because if we look back up at the checklist, we got y alone, we substituted into our other equation, we solved for the remaining variable, we solved for x, we substituted the x back into my y equation, and then finally we want to check our solution. And here's how we're going to do it. I'm going to use my calculator. I'm going to say, I think x equals 3 and y equals 3. So I'm going to say 3 store in my x variable. I'm going to say 3 store in my y variable with that alpha 1. And then I'm going to type in my two equations and see if they come out correctly. What is 2x minus y? 3, just like it should have been. So that first equation works out. What is negative 7x plus 7y? 0, just like the second equation says. Now I know for certain got this question correct. Could you have done that by hand, that checking bit? Yeah, these aren't too terrible numbers, but sometimes you might want to check on the calculator. It might be quicker, it might be more accurate. If you're worried about that mental math, then just store them in your calculator and solve. So another one, exactly the same setup. Solve for one variable, get it alone, substitute it in, yada, yada, yada. As you're looking at this, what variable pops out to you as the one to get alone? Well, I'm looking at this, and again, I see x all by itself. Yes, there's a negative, but I think I can get that x alone pretty easily. So I'm going to get x alone here. I'm going to say negative x equals 4y plus 23. And then divide everything by a negative. X equals negative 4y minus 23. Half box. Now that we've taken care of step 1, we've gotten x alone, I want you to pause this video, substitute it into the first equation, I should say, substitute that alternate definition of x in and solve it out. Okay, I want you to pause it. Pause it, try it, and then hit play and see if you get the same answer I do. So once you've had a chance to pause it, I'm going to start working it out. I'll explain it, and we'll see if we get the same thing. So go ahead, hit pause. And if you're here now, I'm assuming you hit pause and worked it out, and now you're hitting play to make sure you got it right. So I'm going to take this second equation, say 8x plus 4y equals negative 16. Well, that means that 8 times something plus 4y equals negative 16. And what is that something? Negative 4x's minus 23. And I got that from right here. I know from the second equation that x equals negative 4y minus 23. So I'm just going to plug it in right there. Continuing to solve, I'll distribute negative 32x's minus, and maybe I don't know that one off the top of my head. I'll go, what is 8 times 23? 184. So 8 times negative 23 minus 184 plus 4y equals negative 16. So I'm sorry, I made a mistake. I made definitely a big mistake. When I substituted in, look at the yellow, look at the red, negative 4y's. I was gonna try to combine like terms and I wasn't able to. This should have been a y. I just wrote it down wrong. So negative 4y's when you're substituting in, make sure that you're being careful. Really easy to make careless mistakes as we just saw. So negative 32y's minus 184 plus 4y equals negative 16. I'm going to combine like terms. So negative 28y's minus 184 equals negative 16. I need to add 184 to both sides. So I'll say, what is negative 16 plus 184? 168. So 168 is equal to negative 28y's. And then divide both sides by negative 28. Divide by negative 28, negative 6. This is a good sign. When it comes out cleanly like this for a textbook problem, probably a good sign that we did something correctly. However, we can check our work at the end and we'll know for sure. So we're saying y equals negative 6. We think it does anyway. So based on that, I accidentally erased my negative as I was going for my highlighter. Based on this, y equals negative 6, let's plug that back in and say that x equals negative 4 times something minus 23. That something being the negative 6 we just found. So x equals negative 4 times negative 6, positive 24 minus 23. It looks like x equals 1, which would mean that x comma y equals 1 comma negative 6. But before we celebrate, let's check it. I'm going to store 1 in my x value. I'm going to store negative 6 in my y value. And I'm going to type in my two equations. So 8x plus 4y negative 16. That first equation checks out. That's exactly what I should have gotten. What about the second one? Negative x minus 4y, 23. Feeling really good about this answer. I am ready to box it. So this is the substitution method, and this is one you gotta know, you gotta be really comfortable with. What I would like you to do is just try to solve this one. No starter, no hint from me. Okay, one hint. Step one is get one variable by itself. Turns out we actually kind of already have that. So plug that value into the other equation, see if you can solve for x, see if you can figure out what x and y are. I'm gonna work this out and then I'll pause my screen, work it out and unpause it, and you unpause it too, and we'll see if our answers match. All right, I am back with my work on the screen. As you can see, I took y equals negative 4. I plugged that into my first equation for y, which allowed me to solve for x. I got negative 2. And y, I mean, on this problem, we actually had half of the problem done for us. We were told what y was. So negative 2 comma negative 4, you can see from my calculator, I plugged those values into the store function and I checked it. Everything looked good. So xy equals negative 2 comma negative 4. X was negative 2, y was negative 4. So just two more types of problems I want us to look at and make sure we are aware of what they mean exactly. So looking at this first one, 6x minus 8y equals 2, negative 18x plus 24y equals 6. The question being, which variable is the easiest to get alone? There's not really one that jumps out at me as super easy to get alone. So I'll just come down here and say 6x minus 8y equals 2. Maybe I'll get x alone. 6x equals 8y plus 2. I need to divide everything by 6. X is equal to 8 divided by 6, simplifies to 4/3 y. And then plus 2 divided by 6, which simplifies to 1/3. So, okay, fractions, we don't love them. but we can deal with them. Let's come over and grab our second equation. Negative 18x plus 24y equals 6. Negative 18 times something plus 24y equals 6. And I'll fill in my alternate definition for x. So this is where we're at. Now, a little bit of fraction work, but I'm going to remind you, when I'm distributing this negative 18, and I'll come off to the side for this. What is negative 18 over 1 times 4/3? If you remember, we can kind of simplify top and bottom, even if it's diagonal when we're multiplying fractions. So 18, I'll say negative 18 turns into negative 6 if we divide it by 3, and we divide this by 3, we get 1. So that looks like negative 24 over 1. So I'm going to say negative 24 plus, what about distributing the second one? Negative 18 times 1/3. Well, what is negative 18 over 1 times 1 over 3? Let's do the same, simplifying. We get negative 6 over 1. So plus a negative 6. Is what it comes out to when we distribute that 18. I did forget to put my y. I keep doing that in this video. I apologize. Negative 24y's plus negative 6 plus 24y's equals 6. And so we say, let's combine like terms. Negative 24y's, positive 24y's. So we get negative 6 equals 6. And that's a problem because negative 6 does not equal 6. Of course it doesn't. So what does this mean? This means that there is no solution. This means these are parallel lines. Think back to in 3.1, solving by graphing. We said anything that was parallel had no solution. So how does that look algebraically? If we get something that makes no sense whatsoever, negative 6 equals 6. No, it doesn't. If we get something that makes no sense whatsoever, then it's no solution. Those are parallel lines. And we could get them in slope-intercept form and try it. So one more problem, and some of you guys might know where this is headed, but let's say, again, there's not really a great one to get by itself. Let's say I get x alone. So I'm going to say 6x is equal to 7y plus 1, and x is equal to 7/6 y plus 1/6, because I divided by 6 everywhere. And so I'll take my other equation and say negative 12 times something plus 14y's equals negative 2. I'll fill in my something, 7/6 y plus 1/6. So 12 times 7/6 y. The 12 and the 6, again, coming off to the side, can kind of be simplified. So negative 12 over 1 times 7/6. Divide them both by 6, we get that. So negative 14 over 1. So we get negative 14y's. And then we have 1/6. So I'm going to come over to the side and say, what is negative 12 over 1 times 1/6? Divide by 6 again to simplify this fraction a little bit. Negative 2. So negative 2 over 1. So we get negative 14y minus 2 plus 14y equals negative 2. And negative 14y plus 14y are gone. So negative 2 equals negative 2. And what does this mean? Well, the last example, I said if something makes 0 sense, negative 6 doesn't equal 6. That means no solution. What if something makes too much sense? Negative 2 equals negative 2. Yeah, that's a true statement, and there's nothing we can do to screw it up. No x or y value can we plug in to make negative 2 not equal negative 2 somehow. So what does this mean? This means that this is a dependent system. And if you remember that piece of vocab, That means there are an infinite number of solutions because these are actually the exact same line lying on top of itself. And again, we could graph it just to confirm, but these two equations were basically the same equation. If you look, you can say, what if I divide that top equation by -2? I'm going to get exactly the bottom equation. And so that's why when we were working through algebraically, we got something like -2 equals -2, which of course it does. If you get that, that means you have a dependent system with an infinite number of solutions. But guys, substitution, this is the method. This is get one variable alone, plug it into the other equation so that you can solve. I'm hoping this video was helpful as a refresher. Again, I expect you guys have seen this before, but seeing is a long way from having it completely mastered. So let me know if you have questions. Either email me or next time we have class, go ahead, bring it up. But substitution, make sure you have a lock on this. One of the most important things I can make sure that you know all year. So with that, we'll go ahead and end this video, and next time we'll be talking about the elimination method, which is another great way to solve systems of equations algebraically.